Last time, we built the periodic table from one rule: fill the lowest shell first. But I lied a little, because shells aren't really shells. They've got layers inside them. And once you see those layers, the whole shape of the table starts to make sense. So, okay, an electron doesn't actually orbit the nucleus. Not like a planet, it just lives in a region called an orbital, basically a 3D shape where it's likely to be hanging out. And here's the thing, there are only 4 shapes that matter. We call them S, P, D, and F. Each one holds a fixed number of electrons, and once you know those numbers, the table just snaps into place. Let's start with S. The S orbital is a sphere, just one shape. No direction, no orientation, nothing. One orbital, 2 electrons. That's all it can hold. Now, look at the left edge of the table. 2 columns wide, hydrogen, lithium, sodium, all the way down. That's the S block. 2 columns, because S only holds 2. But then we get to P. And P is different. It's shaped like a dumbbell. And there's not just one. There's 3 of them, pointing along X, Y, and Z. 3 orbitals, 2 electrons each. So, 6 total. And now look at the right side of the table. Count the columns. 6. Boron, carbon, nitrogen, all the way to neon. That's the P block. 6 columns because P holds 6. Then comes D. And D is where things get weird. 4 of them look like cloverleafs. 4 lobes, like a daisy. And the 5th one is a dumbbell with a donut wrapped around the middle. 5 shapes total. 5 orbitals. So 10 electrons. And that gap in the middle of the table, the one we talked about last time, count it. 10 columns wide. Scandium to zinc. That's the D block. The transition metals are literally just D filling up. And then there's F7 orbitals. And the shapes are so weird. Honestly, nobody draws them properly. They look like flowers, propellers, weird lobes everywhere. 7 orbitals, 14 electrons. And those 2 long rows hanging off the bottom of the table. Count them. 14 across. The lanthanides and actinides. That's the F block. So look at what just happened. S holds 2. P holds 6. D holds 10. F holds 14. 2, 6, 10, 14. And that's literally the shape of the periodic table. The S block is 2 wide. The P block is 6 wide. The D block is 10 wide. The F block is 14 wide. The table isn't shaped like that because somebody arranged it. It's shaped like that because that's how many electrons each kind of orbital can hold. Okay, but here's a question. If D holds 10 and F holds 14, why don't we see them in the early periods? Because shells aren't actually filled in number order. They're filled in energy order. And it turns out 4 sits a little lower than 3D, so 4 fills first. That's why D only shows up in period 4, and F sits even higher. It doesn't show up until period 6. That's why the table grows wider as you go down. Deeper subshells keep opening up. So the next time you look at the periodic table, don't see rows and columns. See 4 blocks, 4 shapes, 2, 6, 10, 14. The table isn't a chart. It's a map of orbital geometry pinned to a wall.